Hello guys, welcome to another section of this wonderful tutorial. In this particular tutorial, we are going to discuss about variables, data types, and then operations. In the variable part, we will discuss about what variable is, how to name your variables in C++, and then how to declare and then initialize variables in C++. A variable is simply a container for storing data. It's how your program remembers the information that it stores. So in simple sense, I would like to demonstrate how variables work in C++ with the basic code here. So in my terminal, in naming variables in C++, the variable name is just a normal name in English or any language of your choice. So say for instance, I want to create a variable that stores the age of an individual. With this, looking at what I have here, you have to first of all declare the data type of the variable name, and then the value that the variable should hold. Let's start with the rules for naming variables. When naming a variable in C++, the name of your variable should either start with a letter or an underscore. There is no circumstance where your variable name should start with a number or a special case character. So let's try this. I want to create a variable that stores the age of an individual. So with this, I first of all have to declare the data type of the variable, and that will be an integer. So in C++ we do int. And then with the naming conventions followed, first of all, the name of my variable should either start with a letter or an underscore, a letter or an underscore. So I choose to start with a letter, so H. Then I end with a semicolon. So we use semicolons in C++ to terminate our statement. It's somehow like a period in English language. So this is how you name this is how you initialize variables in C++. So let's try in a case where I want to store a variable name amount, right? And data type of this variable should be float. So float amount, ending with a semicolon. With this, I'm following the convention or the defined way of naming variables. The moment I start this variable name is with a letter, my ID try to yell at me, meaning I'm not supposed to start a variable name with a number, as simple as that. Let me try with a special case character like the $sign here. See, no error is shown. Let me try with asterisk. Doing this gives a different meaning. So the best approach is to either start with a letter or an underscore. That's the best thing to do. Don't try to start a variable name with any other special case character. Now let's move on to variable initialization. This is how you declare a variable in C++. Let's move to how to initialize a variable. So initializing a variable simply means assigning a value to the variable, right? So with the example that I have here, I could simply assign a value to age. So age, I could give age 20. As simple as that. So in line 9, I have initialized the value of age. So age is now 20. The value that you assign to your variable should correspond with the data type that you give it. So for instance, the data type of age is an integer. There is no way I can assign a different data type or a different value to age which is not an integer. So let's say I do something like let's say I give it a string. You see, I get an error because hello is not an integer. That's a rule of thumb to follow. So the value you assign to your data type should correspond, the value you assign to your variable should correspond to its data type. Wait, I have not explained what a data type is. So we are moving on to data types. So data type is simply the kind of data that your variable can store in your program. So for C++ comes with some basic or fundamental data types, and these are integers, floats, double, char, and bool. For integers, we have various types of integers that you can have in your program. The same for floats, double, char, and then boolean. As the name suggests, I would like us to take a look at a boolean, right? A boolean is used to store either a true or false statement, or a conditional statement, or simply a statement that requires a yes or no answer. Okay? And characters, as the name suggests, stores characters in the form of ASCII, right? In ASCII code, American Standard Code for Information Interchange. So characters like A, B, C. I'm just mentioning the English alphabet. And then double. Double is somewhat like values in decimals, right? The same applies to floats, but their difference is in the size that they take in your program. So let me just jump into the code and demonstrate some things to you here. So I have this age, which is an integer, and I have amount, which is float, right? Now, integers and floats, they have different sizes that they occupy in your program. So say for instance, I want to know, I just want to print out the size of integers, right? So I just use size of int. Let me just copy and paste this line here and make this part float, right? Let me do the same for the rest of the other integers, and let's see what we get. Great. So with this, I'm just going to run the program, and I want you to keep track of the way I've structured line 13 to line 16, so that you will know the value of the size that each data type takes in your program. Let me clear the screen and then compile your compile the C++ code here. Compile this code, I just have to call the compiler gen++, and then the name of my source file here, that is main.cpp. Then I have to specify the name of the executable file that will be produced at the end of the compilation. So main. Now the program is done compiling. I can simply run the executable. If you're on Windows, you can simply run main and then you type enter, right? If you're on Linux, you just do this and that should work. So the values I have here are simply the size of each data type in bytes. So for integers, we have 4 bytes. So the moment you declare a variable which is of a data type int, that variable can occupy up to a size of 4 bytes in your program. Float also occupies 4 bytes, and the boolean takes just 1 byte, which is equivalent to 8 bits. Character also takes 1 byte, which is equivalent to 8 bits. So it is very good if you have an idea of the size that each data type takes, right? These values might be different for depending on the kind of system you are using. I'm actually using a 64-bit system. Maybe if you're on a 32-bit system, yours might be different. But I think for char and bool, you have the same value. And take a look at type modifiers. So as we have the modifiers adjust the size or sign of data types. So when you take a look at this integer data type here, this includes both positive and negative whole numbers. So in a situation where I want to restrict this to just positive whole numbers, I simply have to apply what we call the unsigned int, right? Unsigned int. So just this, I can simply do sign something like. So this unsigned, doing this will give a range of values for each, and we have this short, right? So short, using short on an int will just decrease the size in memory that the integer data type will take. So let's say I want to modify this to short, just to conserve memory. Short int. These are type modifiers. So I can actually check the size of short int here. Let me see this. Let's work here. I can actually check the type here. I have made changes to my source file, so I have to recompile again, and then so now you see short int is just taking 2 bytes. Look at this massive decrease. Initially it was just the integer alone was just 4 bytes, but just adding the type modifier called short, it has just decreased the size to 2 bytes. So depending on the kind of value that you want your variable to store, you should be very conscious about type modifiers. As simple as that. So with this, you can be playing along with some of the type modifiers that we have here. Yeah, if I apply long will make the int data type have a lot of take a lot of memory. Great. So you can try them yourself. Then let's see this wonderful data type here, strings. Strings are not actually fundamental data types in C++. They are built from characters, right? They are built from characters. I don't want to go into details about the implementation of strings because it will involve me explaining how to use arrays in C++, which we are not up to that section yet. So with strings, we have two ways to store strings in C++. Either we go the C style strings or we use the string class in C++. So first of all, let me show you how the C star strings and then the using the string class in C++. So let me just show you something here. Let me clear this. So I want to have a string that stores the name of a person. So star, the name, the variable name, username, and then I have, let's say, Frank Aqua. So this is the C star, right? This is somehow like me declaring an array that stores the following characters: FRANK space bar ACQUEH. As simple as that. As you can see from this section, I can actually print just username. Can actually print this. Let me recompile and then So I have Frankakwa here. This is the C-style way of declaring strings in C++. Let me clear the screen, and then there's another way too. Okay, instead of doing this, I can try to do this, right? And I think this one too should work. Okay, I have a warning anyway. I have a warning, but I think I should be. It worked. It worked. But I think the first approach is fine. First approach is fine. Now let's look at the C++ style using the string class. So with the string class, I have to include a header file. It's called string. So this is a header file that contains the string class. So with this, I simply have to So with this, as you can see from what we have here, with this, I simply have to set the data type of the variable to string, then assign a value to it. Okay, we don't care about the implementation yet. Let me show you something here. So std string username. Terminate this, and I can then print the value of username. So you see, we had the same result. Okay, so anyway you want to declare strings in C++ is fine. But let's take a look at the size, right? So I want us to check the size of this username and get some information from it. So with this, let me just use the size of, let me just print size of, the size of username. I want to check the size of username in my program. Let me recompile again. So it's taking about 32 bytes, right? 32 bytes. It's taking 32 bytes because I have how many characters here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 times uh okay. So I have 8. Okay, 8 times 12. 1, 2, 3, 4, 5. So 32 bits. So let me check this. Let's So you can just be playing around with this and be checking the sizes depending on the how you implemented the strings. Fine. But I think this they just add up the size of each character here to get this 32. You can check it out at your end, or you can Google it and see. Now we have another keyword, the auto keyword. Okay, you use the auto keyword if you don't actually have an idea about the data type of the value you want to store. So say for instance, I'm writing a program that fetches information from a server. Okay, and then the information from the server, I don't know the data type of that information. With this, I can simply use auto to directly infer the data type of the value I'm storing. So let's check this out. So let me use auto age equals 40. So automatically the type of age is int, right? So all the auto keyword directly infers the data type of the variable, as simple as that. And let's move on to const. There's another keyword called const, right? Const. This is a keyword in C++, and use the const keyword if you don't intend to change the value of your variable in your program. So let's say, for instance, I have this variable called interest rate, which is a float, right? Float interest rate. Let me set it to 0.001. And during the execution of this program, I don't intend to change the value of interest rate. But it's to prevent any part of my program from changing the value of interest rate, I have to add the keyword const to it. So this const keyword attached to this variable simply says that the value of the variable interest rate, that is 0.001, cannot be changed during the execution of the program. That is exactly what the const keyword does. So let's move on to operators, and that will be all for this section. So operations in C++. Operations in C++, we are simply want to talk about the kind of operations that can be performed on the various data types that we have discussed. So let's say if we take an integer, what are some of the operations that can be performed on integers? If we take characters, what are some of the operations that can be performed on characters? The same applies to booleans. What are some of the operations that can be applied to booleans? And that's the job of operators in C++, right? So we have different kind of operators. We have the arithmetic operators, we have the assignment operators, we have the relational operators, the logical operators, increment and decrement operator, right? Now, the arithmetic operator, as the name suggests, allows you to perform mathematical computations. So back in your basic schools, we were doing addition, subtraction, division, and then multiplication. And these are the operators that are used to perform this kind of operation. So we have the addition operator for adding, subtraction for performing subtraction. We have multiplication, we have the division, and this last one is the modulus. The modulus just returns the remainder after division, as simple as that. And then we have the assignment operators. We used one assignment operator here, and that is the equal to operator. Assignment operators are used to assign values to a variable, right? So with the equal to operator that was used here, we use the equal to operator to assign a value 0.01 to the variable interest rate. We also have the plus equal to. Let's just jump straight to the code to see how these operators work. So let's start. We are already cool with the equal to operator. Let me create a variable, say int student size. Okay. So student size, let me use the equal to operator to assign it a value 30. Now to use this sign, this operator, the plus equal to operator. The plus equal to operator allows you to increase the value of the current value of a variable by a certain amount. So say we want to increase the value of student size by 5, right? To do this, we can use plus equal to, and this is how we do it. So student size plus equal to 5. So all that you are doing in line 12 is that you are increasing the value of the current value of student size by 5, so it will be 35, and then you are reassigning the result back to student size. As simple as that. It's more or less like doing, let me comment this, it's more or less like doing student size is equal to student size plus 5. Then this line speaks for itself. So those who are from the math background, you would think that this will give a problem, but the way program works, the way program works in the computer is quite different. So what that is happening is that you are taking the current value of student size, which is 30, and then you're adding 5 to that current value to make it 35. Then the result after this computation is now reassigned back to student size. So now student size is now updated to 35. As simple as that. The same applies to this sign, the minus equal to. For this, you are decrementing the current value by a certain amount, and then reassigning the result to the variable. So let me just try for that, and then you do for the rest of the operators, the arithmetic operators. So I can simply do student size minus 5. So I'm expecting the current value of student size to be reduced by 5, and then the result after the reduction is reassigned to the student size variable. To make this thing clear, let me print out the value of student size after decreasing it by 5. So student size so let me do this, and then so 25 as expected. So you can actually pause this video and then try for the rest of the assignment operators, right? You can try for the rest of assignment operators. The arithmetic operators are quite intuitive, right? You can just try them out. And then the relational operators. The relational operators are used to compare, like they are used to compare values, right? So say for instance, if you want to check, say for instance, I have two values here. Okay, let me clear this. Say for instance, I have a variable, let's say int student size. Okay. School size school B. Let me say school B is 20 and school C is 30, right? And then I would like to, let's say, compare the size of school B and then the size of C, right? Now I can use these comparison operators depending on what I want to do. So if I want to check if the two values are equal, I use this relational operator equal to. So let me just print the results. So school B so school I want to check if the school B size is equal to school C size. Now this comparison method returns a boolean. It returns either a true or a false. So let me compile this and let's see the results after our compilation. Let me save. Make sure you save the file and then you compile. we had 0. Okay, so Boolean in C++ is interpreted as true or false, and the true value is interpreted as 1. A false value is interpreted as 0. So looking at the comparison we did here, we are checking if school B is equal to school C, and this is false. That's why we had 0. We can also check, use greater than sign. We are checking if school B is greater than school C. Looking at this is false because 20 is not greater than 30. But anyway, let's compile and see what we get. As we expected. Now let's use this sign. Let's change the sign here. We'll compile again. And then now this time we had a true value because school B is less than school C. Okay. That is the use of relational operators. So just make sure you understand that relational operators